components of a vector. Suppose your displacement is along this direction. So A is a vector and it represents a displacement. Then it is a combination of two displacement. Along the x-axis there is a component, that is ax. This component is ay. Instead of going directly, you can move this side and then go there. So it's a combination. So a vector can be written as combination of these two. I cap is the unit vector along the x-axis. So this vector is ax I cap. Then this is along the y-axis. So that vector is ayj vector. So already you have studied triangle law of vector addition. So this a vector can be written as axi plus ayj. It is representing two sides of the triangle. Then third side is the resultant of these two vectors. Now resolution of a vector. So a vector can be resolved into components. Now this is a two-dimensional. This is three-dimensional Cartesian coordinate system. Ax along the x-axis, ay along the y-axis, az along the z-axis. So now there is a vector, a vector. So a vector can be written as axi plus ayj plus azk. So this is what is known as resolution of vectors. Now here you can see the angle made by a vector is theta. With x-axis it makes an angle theta. So this component is a cos theta. Ax is a cos theta, ay is a sin theta. Then magnitude of a vector, that can be written as a. This is a vector, a vector. This arrow mark is not there. So this is the magnitude of a is square root of ax square plus ay square. Similarly here magnitude of a vector is square root of ax square plus ay square plus az square, where ax, ay, az are the components of a vector along the x-axis, y-axis and z-axis respectively. Vector addition using components. A vector can be expressed in the form of components. Now a vector is axi plus ayj plus azk. B vector is bxi plus byj plus bzk. Then a vector plus b vector, the sum of these two vectors. For getting the sum, you have to add the corresponding components. This is the x component, this is the y component, this is z component. When you add x component, ax plus bx, then I. So this is the x component of the sum. Now y component, ay plus byj plus az bzk. Now let us see an example. A vector is 2i plus 4j plus 5k. So this is the x component. It's a y component and this is z component. And another vector, b vector, 3i plus 6j plus 4k. Now a vector plus b vector. You have to add the x component. 2 plus 3, 5. 5i. 4 plus 6, 10. 10j plus 5 plus 4, 9k. So this is the sum of these two vectors. You have to add the corresponding components. Now b vector plus a vector. 3 plus 2, 5. 6 plus 4, 10. 4 plus 5, 9. So you can see a vector plus b vector is same as b vector plus a vector. So from this is clear, vector addition is commutative. Subtraction of vectors using components. A vector axi plus ayj plus azk, b vector bxi plus by plus bzk. Now a minus b vector, you have to subtract the corresponding component. Now ax minus bx I plus ay minus by j plus az minus bz k. So one example, a is 2i plus 4j plus 5k, b vector is 3i plus 6j plus 4k. Now a minus b vector, a vector minus b vector. So you have to subtract 3i from 2i. So 2i minus 3i is minus I, 4 minus 6 minus 2j, 5 minus 4, 1k. So this is a minus b. Now let's get b minus b vector minus a vector. 3i minus 2i. So it's I, 1i. 6j minus 4j. It is 2j. 4k minus 5k. It is minus 1k. So you can see a minus b is not same as b minus a. B vector minus a vector is the negative of a vector minus b vector. See, here it is minus I minus 2j plus k. Here I plus 2j minus k. That means b vector minus a vector is opposite to a vector minus b vector. Thank you for watching.